Hello friends, in this video we are going to solve GATE previous year's question from the chapter Engineering Mechanics. So friends, this is a GATE question from the year 2015 set 2. So what the question is saying, a small ball of mass 1 kg moving with a velocity of 12 meter per second undergoes a direct central impact with a stationary ball of mass 2 kg. The impact is perfectly elastic. So the value of coefficient of restitution is 1. So what they're asking, the speed of in meter per second of 2 kg mass after the impact. So let's say friends, this is a ball, 1 kg mass, 12 meter per second is the velocity. This is another ball, this is M2, which is having a mass of 2 kg. Initially its velocity is 0. Let's say they make an impact, and after that the situation is something like this. This is 1 kg and this is 2 kg ball, v1 and v2. We don't know the direction. Let's say this is the direction, I am assuming it, I don't know the exact value. So now first of all, from conservation of momentum, I can write m1 v1 plus m2 v2 is equals to m1 v1 dash v2 dash m1 v1 plus m2 v2. So we can write 1 into 12 is 12, v2 is 0, so this is 0, equals to v1 plus v2. Let's say this is equation number 1. So now from that, using the relation of coefficient of restitution, since it is mentioned that it is perfectly elastic, so E is equals to basically v2 minus of v1 upon v1 dash minus of v2 dash is equals to 1, which is velocity of separation upon velocity of approach. So we can write it as v2 minus v1 is equals to v2 dash is 0, v1 dash is 12, so it is 12. So this is equation 2. So solving these two equations 1 and 2, we will get v2 is equals to 24 upon 2, which is 12 meter per second. Sorry, 24 upon 3, which it is 2 v2. My m2 is not 1, it is 2, so 3, so it is 24 upon 12, which is 8. So the right answer is 8 meter per second. 8 is the right answer. Now moving to the next question. So friends, this is a GATE question from the year 2015 set 2. So what the question is saying, the initial velocity of an object is 40 meter per second. So u is 40 meter per second. The acceleration of the object is given by the following expression: a equals to minus of 1.1 v, where v is the instantaneous velocity of the object. The velocity of the object after 3 seconds will be. So friends, we can write it as a equals to dv by dt is equals to minus 1.1 v, which can be further written as dv upon v is equals to minus 0.1 dt. If you integrate it, we will be getting it as ln v, where the lower limit of velocity is 40, initial velocity is 40, final is v, it is 0.1 t equals to 0, it is 40, and t equals to 3 they have asked. So we can write ln v minus of ln 40 is equals to minus 0.1 into 3, which we can further write it as ln v equals to ln 40 minus of 0.3. Solving this, you will be getting the value of v as 29.6327 meter per seconds. So friends, this is the right answer. Now moving to the next question. So again friends, this is a great question from the year 2015 set 2. It's a truss question. What the question is saying, the magnitude of the force in the member SR. So first of all friends, I will take moments about point P equals to 0. So when I take moments about point P, I will write external forces are QR is equals to F of V. Because since this is a roller joint doesn't have horizontal components. F at H is equals to 0. They have only vertical components. So FQR is equals to FV for this particular case. So we will write the equation as 30 into the distance is 2 meter. If you see 30 into this distance, it is 2 meter, minus of, this is fv, I will write fv into this distance, the whole, which is fv into 3 equals to 0. So fv will be basically 20 Newton. So now friends, if fv is 20 newtons, now I will consider this point. I will draw the fbd of this point, point r. So I can write it as, let's say this is f of qr, this is f of rt, and this is, sorry, this is f of sr. So some of the equations you can write it as f of rt. See friends, what will be this angle? This is 1 and this is also 1. So this is 45 degrees, since TQ is equals to RQ. So this is 45 degree. You can write directly. So FRT cos of 45 degree plus of F of QR is equals to 0. You can write. So basically F of RT can be written as minus of F of QR upon cos of 45. Similarly for x direction, because I have written it for y direction, for x direction we can write f of sr plus f of rt sine of 45 is equals to 0. So f of sr can be written as minus of frt into sine of 45 degree. See friends, frt can be replaced here, so we can write it as f of sr equals to minus of f of qr cos of 45 degree into minus of sine of 45 degree. So friends, as we know that cos 45 and sine 45 have the same value, so this will get cancelled. So it is f of qr. So f of sr is equals to f of qr, which is f of qr is equals to f of v, which is 20 newtons. So it is 20 newtons. So right answer is C, option C. 20 newton is the right answer. Now friends, moving to the next question. So friends, this is a GATE question from the year 2015, set 3. So what the question is saying, they have given a weight of 500 Newton is supported by two metallic ropes. T1 and T2 are the tension in both the ropes. And what they have asking the value of T1 and T2. So friends, I will just draw the diagram. It is 500. This is T2. It is 120 degree. This is something T1. This is 90 degree. And since it is a point and a sum of angles around a point is 360 degrees, so it will be 150 degree. Now I will use Lami's theorem. I know you might have learned about Lami's theorem in your 9th, 10th or 11th, 12th engineering examinations, also in college first year, also in JEE or Triple E preparation also you might have gone through Lami's theorem. So I will use Lami's theorem only, or you can use it, you can tell it as sine rule. I am basically using sine rule only. So how it is that T upon sine of 120 is equals to 500 upon sine of 90 degree is equals to T2 upon sine of 150 degree. So T1 can be written as 500 sine of 120 degree, which is 250 Newton. Similarly T2 can be written as 250 root 3, which is 433 Newton. So the right answer is option B. Option B is the right answer for this particular question. Now moving to the next question. So this question is from GATE year 2015, set 3. So what the question is saying, the question is saying a bullet spins as the shot is fired from a gun. For this purpose, two helical slots as shown in the figure are cut in the barrel. Projections A and B on the bullet engage in each of the slots. Helical slots are such that one turn of the helix is completed over a distance of 0.5 meter. The velocity of bullet when it exits the barrel is 20 meter per second. Its spinning speed in radian per second is what? So now friends, as it is written that one turn of helix is completed over a distance of 0.5 meter. So let's say when it is covering 0.5 meter, it's covering a rotation of 2 pi 360 degree. So for x distance it will be having a value of theta. So we can write it as simply as x by theta is equals to 0.5 upon 2 pi. So for theta equals to, let's say for the time, for the linear speed, we can write is at x equals to velocity into the time, and in the same x distance theta is also covered, and in the same time, see, for the same distance theta is there, and during the same time only it is coming. So it is having some angular speed also. If you look at the question clearly, the for a particular theta it is moving at a distance x. So in the same time theta is also covered and the distance is also covered. So we can write it as x equals to some velocity into t, and theta equals also to some omega into the same t. So again I can write it as x by theta is equals to v by omega. So this is equation 1 and this is equation 2. From equation 1 and 2 we can write 0.5 upon 2 pi equals to v upon omega. So now omega can be written it as 2 pi upon 0.5 into v. They have given the v is 20 meter per second. So 2 pi upon 0.5 into 20. So friends, if you will put the values and solve it, you will be getting the value of omega as 251.8 33 radian per second. So friends, this is the right answer. Now moving to the next question. So friends, what the question is saying? The question is saying a rigid ball of weight 100 Newton is suspended with the help of a string. So this is the string. The ball is pulled by horizontal force F such that the string makes an angle 30 degree with the vertical, the magnitude of force in Newton. So friends, again we can solve it using sine rule. Let's the tension is T. This is 90 degree. This is 30. So this is basically 120 degree. How I can say 120 degree? This is 30, so this is also 30, and 30 plus 90 is 120 degree. So this is 120 degree, and this is again, if you see, this is 90, this is 120, this is 150 degree. So again using sine rule or Lami's theorem, whatever you say, I will write the equation as f upon sine 150 degree is equals to 100 upon sine 120 degree. So it can be written it as 100 upon sine 150 by sine 120 degree. So friends, if you solve it, you will be getting it as 100 root 3. So the right answer is it is 100 upon root 3. If you will put the values in the calculator, you will get 100 upon root 3. And so the right answer is 57.735 Newton. 57.735 Newton is the right answer. Now friends, again going to the next question. So friends, this is a GATE question from the year 2016, set 1. So what the question is saying, a block of mass m rests on an inclined plane and it is attached by a string. So this is the string they have mentioned to the wall as shown in the figure. The coefficient of static friction between the plane and the block is 0.25. So mu is 0.25. It is static friction. The string can withstand a maximum force of 20 Newton. So this is a tension maximum is 20 Newton. The maximum value of the mass for which the string will not break and the block will be in static equilibrium. So first of all, I will draw the FBD. This is mg, the weight in downward direction vertically. This is mg cos theta, the component of weight along the inclined plane and perpendicular to the plane, and this will be the normal direction. Since the body is having a tendency to move in this direction, the friction will come in this direction because it is resisting. Now they have mentioned it is in static equilibrium. Since the body is in static equilibrium, which means that mg sine theta is getting balanced by the tension plus the frictional force. What is Fs? Fs is basically mu s times of n, and for particular this FBD, n is basically mg cos theta. In vertical direction, n is balanced by mg cos theta. So Fs is mu mg cos theta. So what we will do, I will just simply replace the values what they have asked. They have asked the values of m mg sine theta minus of mu mg cos theta is equals to t. So m is basically t upon g. I have taken common sine theta minus mu cos theta. They have given the value of t as 20, g they have told us to take as 10, so g is 10, sine theta is 0.6, and they have given mu as 0.25 into 0.8, so this is 2, this is 2 upon 0.4. You will solve it and get it the value of 5 kg. So m is basically 5 kg. So the right answer is 5. Now moving to the next question. So friends, again this is a GATE question from the year 2016, set 1. So what the question is saying? The question is saying a two-member truss PQR is supported by supporting a load W. The axial forces in the members PQ and QR are respectively. So friends, again I will take the moments around R equals to 0. You will find that the W is having moment in this direction. So W is W into this length. This length is PQ. So W into PQ. If it has to be balanced, then the force of PQ will be in this direction. So FPQ I can write it as minus of FPQ into the distance will be PR into PR, which is equals to 0. So f of PQ can be written it as W into PQ upon PR. So PQ upon PR, basically PQ upon PR is what? If you look in triangle PQR, we can write tan of 30 degree is equals to PR upon PQ. So basically PQ upon PR is 1 by tan of 30 degree, which is root 3. So f of PQ is root 3 times of W, and the direction is in this. So if you can clearly see that f of PQ is basically root 3W, and it is tensile in nature. So if you look at the options, all the other options are eliminated. Option B is the right answer, that is f of PQ is root 3W tensile. But how we will calculate QR? See, we will consider the FBD of point Q. We can write point Q as W is in this direction, f of PQ, since it is tensile, it will be in this direction, and QR will be something I have assumed in this direction. So I can write it as this is angle 60 degree. So f of QR cos of 60 degree plus W is equals to 0. You are will be getting it as f of QR is equals to 2W minus 2W, which shows it is compressive in nature. So f of QR is 2W compressive. So option B is the right answer. Now moving to the next question. So friends, this is a GATE question from the year 2016, set 2. So what the question is saying? The question is saying a point mass having mass m. So this is having a mass of m, is moving with a velocity v, is given at an angle theta to the wall as shown in the figure. The mass undergoes a perfectly elastic collision with the smooth wall and rebounds. The total change final minus initial momentum in the of the mass. So friends, let's say initial what was this? Initial, the ball was moving like this, mv cos theta and mv sin theta before collision. This is before. What will happen after collision? The ball, after since the collision is perfectly elastic, so the direction will get changed. Mv cos theta values will remain same only. So what is the change in momentum? Change in momentum in x in y direction. It is basically, if you look at the figure, or you can write it as final is minus of mv sin theta, because this is the direction, j cap minus initial is in the plus direction. I am taking this as plus j, minus of mv sin theta j cap, for it is v minus 2 mv sin theta j cap. So friends, this is the right answer, option D is the right answer, that is minus 2 mv sine theta j cap.